I'm going to hand the floor over to Matt. Take it away.
Okay. All right, thank you. Hi, everybody. My name is Matt Hansen. I work at Element 84, and today I'm going to be talking about EarthSearch, which is a STAC API that is free to use that we've stood up at E84 that indexes a bunch of data on AWS. So if you go to the registry of open data on AWS, there's actually a ton of data, and you can search for different types of data there. Not all of it is geospatial, of course. If you have any questions, by the way, don't ask me. Chris Stoner's over here. All right, she leads the open data program. But there is a lot of geospatial data, and that geospatial data is hard to use if it's just in a bucket somewhere. So, for example, this is the Sentinel-2 data, and you can get a listing of the bucket, and it's just a bunch of tiles. It's separated by the MGRS tile grid and the date, and it's all these JPEG 2000 files. And that's pretty awkward to use because the data actually within the tile itself might not in fact cover the entire MGRS tile grid. So if your AOI is in a part of the tile that doesn't have any data in it, as in this case where this is a common case where the swath comes down and there's only data on the left-hand side, you could find all of the data tiles that you think that of interest, and you download those and you've wasted your time because there's actually no data in it. So this is where EarthSearch comes in and STAC. So we wanted to index this with the actual AOIs and metadata so that you could search this in an efficient way and access that data. This actually started 6 years ago when we first, in 2019, where we first created the Sentinel-2 cogs from the JPEG 2000s that were directly from ESA. And those were an early version of STAC before the first version of STAC came out. And it was pretty popular at the time, and a few years ago we introduced the version 1 part of the endpoint, and we actually added some new data sets beyond Sentinel-2. So right now, if you go to the EarthSearch URL, you'll see that there's several data sets. There's the Copernicus data, there is the Landsat data. I'll talk more about each one of these. There's the NAPE data, which is just for North America. That's high resolution data. Sentinel-1 and Sentinel-2. The Copernicus DEM data is from 2021. These are all in COGS, and it's of a couple different resolutions here. I'm going to give a demo of the viewer, of a newer version of this viewer that you're seeing here. And all of those COGS, you'll notice, are in EU Central 1 in the region. The Landsat data is in the US West 2. It is actually a requester pays bucket that this data is in. I want to point out that this is the authoritative data, so the USGS actually puts their data in this bucket, and so it shows up in the registry of open data, but this is actually the authoritative source. So unlike if you were to go to Planetary Computer or Google Earth Engine, like those are mirrors of the data, this is the data that is maintained by USGS itself. We have this index, it points to that data. The USGS also has a STAC API that indexes a lot more different types of data set. This one is just the level 2 data because that is what users are most interested in. You'll notice that most of these data sets are pretty consistent in what we use. This is the Landsat data that we're looking at here. We typically use the EO extension to capture cloud cover for any data set that has the cloud cover. We use view angle extension to capture sun angles if those are available. We use the projection extension. This defines the CRS and the affine transformation, and this is really of use if you're using Open Data Cube or ODC Stack. So all of these data sets are compatible with that for the data sets that are backed by Cloud-Optimized GeoTIFFs. And in the case of Landsat, we use this Landsat extension, which has really specific Landsat fields, such as IDs that are specific to Landsat, such as the path row and the original scene ID. Really not of tremendous use for most people, but if you're looking for something specific and have IDs from USGS, that can be helpful. In the Landsat data, we also have captured the QC band here. So you'll notice that. So this asset that we're looking at is the QC pixel, what they call pixel QC band, pixel quality assessment band. And you'll see this is using the classification extension in STAC. And this is a bit field. So like this raster captures a lot of different information. It captures cloud cover for each pixel, shadow, whether or not it's saturated or not. By putting this right in the metadata, then the tools that we use, the clients that we use, can programmatically create masks on the fly. So there's actually some examples using ODC STAC on how you can create masks from these depending on what you want. If you want high confidence clouds and shadows as well, and because it's in the metadata, this makes it very easy to do this on the fly. Back before this, you generally have to research this online and look it up in the Landsat Data Science Handbook in order to figure that out yourself. The NAPE data here, we have this from 2009 through 2022. Most recently, it includes Hawaii and I think Alaska. This is also in US West 2. It says requester pays there. I think that's no longer the case. Chris? Well, I mean, I'm not entirely sure. It might not be requester pays anymore, but the NAPE data is high resolution data. You can see this is a spatial aggregation showing where the data is located, and I want to point out two things that are kind of interest. One is that you see there's a lot more data in North Dakota. If you didn't know that was North Dakota, that's North Dakota. NAPE is collected every 3 years, and it's collected individually by the states, but North Dakota collects it every year. This is probably not of a whole lot of interest to anybody outside the United States, but this is a good example of why looking at spatial aggregations of counts of data is really useful. And again, I'm going to show a demo of that in a little bit. The Sentinel-1 data is 2014 through the present. That's the entire archive of Sentinel-1 data that we have indexed. And just like the last one, it doesn't come out very well on the screen here. But I didn't realize this before we indexed all this data, but most of the Sentinel-1 data actually is collected over Europe. Unlike Sentinel-2, which is sort of even coverage across the globe, but Sentinel-1 is primarily collected over Europe. An interesting thing with the Sentinel-1 data is that in order to, we had to do some additional processing in order to get accurate footprints. The footprints as they come out from ESA are actually pretty rough. As this cycles through again, you'll see the original bounding box includes lots of water. It includes a lot of no data areas. And so we had written this raster footprint utility that goes in and looks at the data and traces a new polygon in order to generate a more accurate footprint of it. It's not completely accurate. Creating footprints in STAC is sort of a trade-off between complexity and accuracy. You don't want something that's overly complex because then the geometries get really, really big. And so this utility does a pretty good job at splitting that difference down the middle. This is now a feature in GDAL as well. We haven't actually compared to see the differences in it, but this utility works pretty well for our purposes, and we had to run it on all the data that we ingested for Sentinel-1. Sentinel-2 is the most popular data set in Earth Search. It's accessed a lot because I didn't update these slides for the requester pays. It is no longer a requester pays bucket. So the API is completely free. The data is completely free, no matter where you're getting this from. So lots of companies have used this. They've used this as part of their pipeline, part of their production pipeline. We do tell people don't use this in production, or at least there's no guarantees that this is going to work. We do this as a best effort. We're not paid to do this, and so you can file an issue or you can reach out to us, but there's no guarantee that this will work, and there's no SLA associated with it. That being said, lots of people do use this because it's free and it works very well. We've had very few problems with this at all in the 6 years that it has been running. It scales very well. In the Sentinel-2 items, you'll see all of the different assets are separated by spectral bands. And if we look into that, you'll see each asset has the spectral band information along with the proj shape, proj transform. These are the fields that are used by ODC STAC. So you can use ODC STAC with the Sentinel-2 data in order to create X-arrays as well. I want to point out the scale and offset. This is generally good practice if you're ever creating STAC yourself. It's common for floating point data to be compressed into 2-byte ints and applying a scale and offset. These are usually encoded in the TIFFs themselves, but we put them in the STAC metadata now as well, so that you know that ahead of time. You should always pay attention to if there is a scale and offset, so you can apply that appropriately to your data if it's applicable. I didn't finish this slide because I was waiting for a graphic that I didn't get, but I do want to point out that there are some missing scenes from Sentinel-2. Sentinel-2 had just done a reprocessing over the last year and a half from what's called, I guess, a pre-collection. Like the original processed Sentinel-2 data was processed into what's called collection 1. I know that this is a overuse of the term collection. We use STAC collections, but collection 1 was a reprocessed version of the entire archive of Sentinel-2. It took ESA a year and a half to do so, I think. And we do have missing data for 2022 that we're looking to backfill over the next, I really can't give you a time because, as I said, this is a best effort. So if you happen to have bags of money, you can certainly approach me afterwards and give those to me, and I'll make sure that that's done promptly. All right, and this is just that's just a repeat of that. The extensions that we use throughout all these data sets, I talked about, I did hint at a little bit of this before, but this is the complete list of the ones that we generally try and use. This is actually just good practice if you're creating STAC yourself. I would highly recommend that you take a look at these extensions and you implement these. I will talk more maybe about that at my STAC talk this afternoon. The storage extension defines where the data is located. It'll define whether or not it's a requester pays bucket or not. The processing extension holds version information about software that was used to process that data. The raster and the projection extensions are used for holding the info that ODC STAC can use. The file extension holds checksum data in case you want to validate the downloads against the checksum that is contained in the metadata. The view extension contains angular data around sun and satellite viewing angles, also moon angles if those are available. They're not for any of this data, but and then if it's gridded data, so like Landsat uses path row, Sentinel uses the MGRS grid, those are specified in the grid extension for STAC. And then depending on the type of collection, the EO is for spectral data, SAR is for radar data, and then I mentioned the MGRS grid, which is for the gridded data. There's a little bit of overlap between grid and MGRS. Grid is actually kind of the more general version to specify gridded data, you can specify MGRS grids along with other types of grids, and the MGRS is probably something that should probably be deprecated at some point. All right, I mentioned ODC STAC a few times. There's pretty small text here, but the way this works is essentially this little code snippet here. You can search the catalog, you get a bunch of scenes, and then you can use ODC STAC load to load those into an X-array. And what it's actually doing behind the scenes is it's looking at that projection and raster information in the metadata in order to pre-construct the sizes and the overall dimensions of the output X-array before it actually hits any data. It's well outside the scope of this talk, but I wanted to include this because it really is one of the most useful, best use cases on how to use ODC. Now, beyond Earth Search, I wanted to just talk about some other stacks because the title of the talk was public data in general. I mentioned that USGS has a API for Landsat. In Earth Search, we just have the level 2 surface reflectance data, so that's the second row right here. If you want something other than the surface reflectance level 2 data, like you want the level 1 data or you want the ARD data, there's a difference. It's kind of nuanced about that. If you want the burned area index or the water extent or any of the other derived products, these are all available in the USGS Landsat API. And each one of these is different collections. NASA CMR. CMR stands for the Common Metadata Repository. It predates STAC. It goes back to 2014, 2015. It's all of the data from all of the different what NASA calls DACs. These are data centers, effectively. I think they hate being called data centers, though. So, but CMR is something they all have to put their data into. And some years ago, 3 or 4 years ago, we created something called CMR Stack, which is a proxy. It's not its own stack catalog. It's actually a proxy that looks and acts like a stack catalog. It's not super fully featured because it doesn't have a lot of the extensions in it. It's pretty bare bones. It provides the core stack information, geometry, date time, and the data files. But there's a huge amount of data in there in CMR that now you can get in a stacky way. I think there's 6,000 collections and perhaps close to 1 billion granules. Microsoft Planetary Computer is also a popular one. We were involved with indexing and creating most of that data on Planetary Computer when it first launched. I still think that it's one of the best examples of a STAC API out there because it was all created by the same team, which was largely us. That's why it's so great. But there's a lot of data, and there's a lot more data than an Earth search. Because of that top-down approach, when you look at any random collection there, you'll see that they're very consistent in how they were created. They're using the same types of extensions, the same formats where applicable and everything. So Planetary Computer is good. I should note that I do not believe that the Sentinel-2, the reprocessed Sentinel-2 has been updated on Planetary Computer, so cautionary note there. If you are using Sentinel-2 Planetary and you're using historical Sentinel-2 data, Planetary Computer is probably not the best place to get that because prior to January or February of 2023, the processing baseline version was earlier, and you really shouldn't be comparing data across that date. The USGS Astrogeology Department got involved with STAC some years ago. This is a really cool public API as well. It turns out they use STAC for the Moon and Europa and Mars data, and there is a UI that you can go and browse that data, which is pretty cool. They worked with us for a little bit to update some of the extensions so that they could accurately represent different planetary bodies within the STAC spec. And you can go to the STAC Index website, and if you have public data, or even if it's not public, if it's behind a firewall, that's okay. I highly encourage you to go and drop that into STAC Index. And lastly, just as I'm out of time, I just wanted to show you a quick demo. This is the new Earth Search console. That's not the new Earth Search console. This is the new Earth Search console. This is running locally. I wanted to get this deployed before this week, but I was unable to. And I talked about the spatial aggregations. I'm going to show you here Sentinel-2. So you can do a search for, let's just search the entire archive of Sentinel-2 data. And we're going to look for things with low cloud cover. And we're going to search. And that gives us a hex grid of where that data is located. I don't know of too many other platforms that take this approach of doing spatial aggregations. It's not supported by, I don't think it's supported by any other STAC API implementation other than the one that we use for Earth Search, which is called STAC Server. It is a STAC extension, and it's backed by OpenSearch. And you'll see that this aggregated 2.6 million scenes in real time. So it's a great way to look at where your data is located because you can perform any arbitrary search for whatever angles, for cloud cover, and see exactly where your data is located rather than having to know where your data is located and zoom in order to look at those footprints. And I think that that is it. Thank you.
Folks have questions for Matt?
Matt,
Yes, Alex.
how large a bag of money do you need to fill in that gap in the collection 1 data? Because it's stopping me from using it right now.
$1 million. No, it's a good question. It probably wouldn't take much. I mean, we're tens of thousands of dollars, $10,000, $20,000, $30,000 US, something like that. It's not. It's you have it right there. Yeah. Yeah, I'd love to do it. It's just a matter of resourcing. We might actually be in a position over the next few months where we might be able to fix this problem once and for all. It's kind of been a thorn in my side now for a year or so. I will mention that ESA took 1.5 years, I think, to process all that data, and we did it in 3 weeks. So if we actually have the resources, we'll be able to fill in that gap really quickly.
I think we need twice that amount, but
Yeah, people always do tell me to double my estimates.
that was too low.
60. Anyone have a 60K or another question for Matt?
Only to the question.
Just a question.
How's STAC set up for like bigger data sets like Landsat Next when it comes? Will it be able to handle? Do you know of anything in like Landsat Next that STAC won't be able to handle?
No, I don't think so. I mean, that really comes down to the implementation, right? We use OpenSearch. I'm a big proponent of OpenSearch. I may or may not talk about that in my next talk, depending. I know I'm being kind of mysterious about that, but it might come up. If you're doing something like Postgres, and after some years, I mean, the problem, right, is just like after 10 years, you're going to have a lot of data. So certainly at the beginning, there won't be any problem.
Similar kind of question. With ESA potentially moving to ZAR, do you see any sort of major changes that will need to happen on your end, or will it just be pointing STAC to ZARs instead of COGS?
Yeah, so no, that's a great question. So the way that it's currently planned out, so for like level 1 and level 2 data, where there isn't really a whole lot of difference, right? Like a ZAR data set is still going to represent one granule. You really need for it to do that because there's metadata that is specific to that granule, such as view angles and that sort of thing. Once you get to level 3, and you can have like a big global homogeneous data set that's different. But yes, I see it pretty much working the same way. You'd still search for granules. It's just that the assets would be pointing to a ZAR data set instead. And then for like higher level data, you might have a collection for like the level 3 data set, perhaps, and that is, and at the collection level, you're pointing to one big global data set. That's kind of a quick answer, but happy to talk about that more. Any other questions?
Thanks so much, Matt.
All right, thank you.